In this video, we're going to talk about the limiting reagent. Okay, so I'm going to explain the basic concept of the limiting reagent. From there, we're going to see now how the limiting reagent affects the production and all the calculations to do with the limiting reagent. Okay, then finally in this video, we are going to talk about the percentage yield. So how does the products depend on the limiting reagent? Okay, so a limiting reagent basically is a reactant that finishes faster before the other reactant in a chemical reaction. So let's say we have A and B as two reactants in a chemical reaction. Then the products of this reaction, let's say we have C and D. Okay, so one thing is very important to note in a chemical reaction. So it doesn't necessarily mean that if you have 50 grams of A, it doesn't mean that even for B you need 50. It's not the case. Okay, let's say you have 50 grams of A and 50 grams of B. So it doesn't mean that they're going to finish at the same time or they are all going to be used up. No. Depending on the molecular mass of the two reactants. So you may find that A may finish faster before B finishes up. Okay. So you find that maybe, let's take an assumption to say after some time, you find that there is 10 grams of B remaining, then 0 gram of A is remaining. Okay. Then maybe you find that on the other hand, you have 30 grams of C and 30 grams of D. Okay. So what does this mean? So this means that in such a reaction, A is the limiting reagent or the limiting reactant because it finishes up faster before the other reactant. Okay, and the one that doesn't finish is the one that is referred to as the excess reagent. Okay, so now that we've understood the basic concept of the limiting reagent, how then do we deal with the calculations? So we will deal with calculations by using the number of moles. Let's try to look at a practice example. So DDT, an insecticide, harmful to fish, birds and humans, is produced by the following reaction. So the reaction has been shown. Okay. So chlorobenzene, DDT in a government lab, 142 grams of chlorobenzene is reacted with 485 grams of chloro. What mass of DDT is formed? Assuming 100% yield, which reactant is limiting and in excess? Justify your answer. Then see, they are saying what mass of excess reactant is left over. If the actual yield of DDT is 200 grams, what is the percentage yield? Okay, so we'll start with the first question, which says what mass of DDT is formed. Okay, so before you get to determine the mass of the DDT which is formed, of course in this case we need to note that this is the DDT that they're talking about. Okay, so chlorobenzene, chloro, in a government lab. Okay, so 1142 grams of chlorobenzene is reacted with 485 chloro. Okay, so now which one is chlorobenzene and which one is chloro in this case? How do you get to know that? Okay, so the first one, C6H5Cl, is the chlorobenzene. Okay, then the other one is chloro. So chlorobenzene is also say benzene is a hydrocarbon. Okay, so the first one, which is C6H5 Cl, which is reacting with C2 HO Cl3. This is what we are saying. This is our chloro, and this is, of course, we are in the ratio of 2 to 1. Okay, so this is chlorobenzene. Then the other one is what? Is the chloro. So now what are we taught? So we are told that 1142 grams of chlorobenzene is reacted with 485 grams of chloro. Okay, so 485 grams of chloro has been given. So now, how do you get to determine how much of the DDT was formed? Okay, so what's the formula for DDT? Okay, so it's really important to determine which one is limiting before you get to answer such a question. Okay, so the way to go about it is you can determine the number of moles of either the first one or the second one, whichever is works best for you. So any of the two is okay. So in this case, I'm going to start with I'm going to determine the number of moles of this one. Okay, and how do I get to determine the number of moles? So I get to determine the number of moles. Of course, we know that the number of moles is given by mass divided by the molar mass. Okay, so we've been given the mass to be 1142. Okay, so we need to divide by the molar mass. So we've been given a formula, it is C6H5Cl. So that's how you get to determine now the molar mass. So we have 6 carbon atoms. The molar mass of carbon is that, the molar mass of hydrogen is that, and that's the molar mass of chlorine. So after doing your calculations, this is what you get as your molar mass, and we divide that into the given mass now. So you have 112.553. So you have 112.53, of course, grams per mole. So this is basically going to give us what? So you have 1142 divided by 112.53. Okay, so after dividing, you're going to have 10.148. So you have 10.148. So these are the number of moles of what? Of this reactant from the mass. So we've determined the number of moles. Okay. So what is the next step? So the next step is now to determine the number of moles of the other reactant that is required by using the mole ratio. Okay, so the mole ratio is 2 to 1. 2 to 1. Then the 10 that we've determined is for this one. So write it under the 2. So it's 10.148. These are the number of moles of chlorobenzene that are present in this reaction. So let's try to determine now how many moles of the chloro is needed. So if you cross and multiply, you have 10.148 multiplied by 1, then divided by 2. You find that your value of x is going to be 5.074. So what does that tell you? That tells you that these are the number of moles of what? Of the chloro that are required to react with the given number of moles of chlorobenzene in this reaction. Okay, so now we've determined what is required. This is what is required by the number of moles that are available. So now let's try to determine now the number of moles of the chloro that are available in this reaction. So let's try first of all determine the molar mass. Of course, the mass has been given. So first to determine the number of moles, we're just supposed to divide. Okay. So the mass is 485. So we have to divide by the molar mass. So if you get your periodic table, you know that carbon, we have got 2 carbon atoms there, so multiply by 12.01 plus 1.008 for the hydrogen plus 15.994 for the oxygen, then plus 3 multiplied by 35 for the chlorine atom. So it's approximately 35. Okay. So after adding, you find that you get 146. So you have 146.02. Okay. So what do you get after dividing? So 485 divided by 146, you have approximately 3.3. So what does this tell you? This tells you to say that these are the number of moles available. Okay. Now 10 moles of the other reactant chlorobenzene requires 5 moles of the chloro, but what is available is only 3.32 moles. So what does that tell you? Which one is a limiting reagent? So it tells you that the chloro is limiting because what is required is actually more than what is available. Okay. So meaning that chloro is going to finish up faster because what is required is 5.07 moles, but what is available is only 3.32. So it's going to finish before the chlorobenzene is done. So in this case, we can therefore conclude that chloro is actually the limiting reagent. So all the calculations determining what is formed, we are going to be working with chloro. Okay. So let's try to move now. So this is one way of determining the limiting reagent. So equally, if we had used now chloro to determine the number of moles of the chlorobenzene that is that are required, let's try to work out. Let's try to do that as well. We see what we're going to have, so that you understand there are 2 ways of going about it. So we've determined the number of moles of chloro that are available in this reaction. Okay, so don't forget that we've also determined the number of moles of chlorobenzene to be 10.146. So these are the moles of chlorobenzene that are required, or that are actually available, and these are the number of moles of chloro that are available. So using again the mole ratio, of course it's 2 to 1. For chloro it's 3.32. These are the number of moles available. Okay, so finding the value of x again. So if you cross and multiply, you find that your value of x is actually going to be 6.64. Okay, so what does this mean? So the interpretation here is going to be the 3.32 moles of chloro that is available in this reaction requires 6.64 moles of the other reactant. But you find that the 6.64 that is required is actually less than what is available, meaning that the other reactant chlorobenzene is actually in excess because the number of moles available are actually more than the required. So equally, we can still say that chloro is limiting because it requires less of what is available for the other reactant. Okay, so whichever is easier for you, but either ways, we've already determined that chloro is actually the limiting reagent. So all the calculations to deal with what is produced, we're going to be working with a limiting reagent. Okay, so the first question says, what mass of DDT is formed? Assuming 100% yield, what mass of DDT is formed? Okay, so now we'll look at chloro with the DDT. In what ratio are they? So they are in the ratio of 1 to 1. Okay, they are in the ratio of 1 to 1. So whatever number of moles of a limiting reagent are available, so say they are in the ratio of 1 to 1. So what number of moles do we have for the limiting reagents? 3.32. So even for, since they're in the ratio of 1 to 1, no need of putting a variable there. We'll just say that it will also require the same number of what? The same number of moles. Okay, so it's 3.32 moles of DDT. Okay, so we have a number of moles. How do we get to determine the mass? So we know that the mass, of course, from a formula where we are saying the number of moles is given by the mass over the molar mass. So if you make a mass to be a subject, you find that the mass is actually going to be a product of the number of moles multiplied by the molar mass. Okay, so the number of moles have already been determined to be 3.32. So now, how do you get to determine the molar mass of a DDT? So we know that you have got 14 carbon atoms. So it should be 14 by 12.01, then 9 by 1.008, and 5 by 35.453. So you have got 354. So you've got 354.477. Okay. So multiplied by 354.477. So you get your calculator there. 3.32 multiplied by 354.477. What we have is 1000. So write that 1176.86. So that's in grams. So this is how much of the DDT is produced. So what is very important is to note is, first of all, determining the limiting reagent in every reaction where they are asking, in every question where they are asking you to determine the amount of the product that was produced. You're supposed to use the limiting reagent because it's the one that is going to determine how much of the products are going to be produced, because it is going to finish up faster. So it will limit how much of the products are produced. That's very important to note. Okay, so we've determined now the mass of DDT that is formed, assuming a 100% yield. Okay, so what's next now? The next question says, which reactant is limiting and in excess? So that was actually the first question that we attempted. We used different calculations to show the limiting reagent, of which we said is chloro. That is the limiting reagent in this case. Okay, so the one that is in excess is actually chlorobenzene, which we already showed that. So now there is a follow-up question which says, what mass of excess reactant is left over? Okay, what mass of so remember, in the question initially, what were we given? In the question we were given that the chlorobenzene was actually 1142 grams. Okay, this is how much of it was available initially. So let's try to determine how much of it reacted using the limiting reagent. So they are in the ratio of 2 to 1. Then I'll write beneath it, I'll write the number of moles. So the number of moles are 3.32 for the limiting reagent. So let's try to find the value of X there. We determine the number of moles of the chlorobenzene that are what? That are required. Okay. So you find that your value of X is going to be 6.64. So we have 6.64. These are the number of moles of what? The number of moles of chlorobenzene that reacted. So let's try now to determine the mass. Let's convert the number of moles to mass. So mass, we've already said, is a product of the number of moles by the molar mass. Okay. So we already determined the molar mass to be 112.53. Then that should now be multiplied by the molar mass, the number of moles, 6.64. Okay. So you have the number of moles being multiplied by 112.553. Okay. So you can grab your calculator and multiply that. 6.64 multiplied by 112.553. We have 747. So we have 747.35 in grams. Okay, so this is how much had reacted, and in the question you are given initially what was available. So for you to determine how much of it was left over, you subtract. So you say 1142 subtract the 747.35. So after subtracting the two, what I'm getting as how much was left over is 394. So I'm getting 394.6. Okay, 394.6 grams. This is how much was left over. Then the other question says, if the actual yield of DDT is 200 grams, what is the percentage yield? So if the actual yield was that, what is the percentage yield? Okay, so let me just try to create enough space. So what is very important is to understand that the percentage yield, the actual yield is actually always going to be less than the theoretical yield. And the theoretical yield is determined from the calculations, the number of moles. So, like, don't forget that in the first question we determined the mass of DDT that was formed, and it was this one here, 1176. So it's going to be the actual over what? Theoretical. Okay? The actual over the theoretical yield multiplied by 100%. So the actual we've been told is 200 in grams. The theoretical yield was 1176 as we calculated, 0.86. Of course it was also in grams, so that's a 6 multiplied by 100. So grab your calculator, 200 divided by 1176.86 times 100. So we have 16.99. Okay, so a percentage becomes 16.99. So 16.99%. So which is approximately 17%. So that's the way to go about it. I just hope this video has helped you understand the concept of the limiting reagent. Okay, so watch out for the next video where I'll solve more questions, more practice questions on the limiting reagent. Thank you very much for watching.